Good day to our fellow Rashira Puamakeshwari. Me and my teammate are gonna present our mini project today, and I myself, Sharuni Raja, and Ang Jihan and Nur Adira will join us. So for the part 1, we have system design for online student information system. SIS is our given project. So SIS and introduction objectives. Introduction, the online student information system is designed to assist lecturers in efficiently managing student data. It provides functionalities such as adding, updating, searching, and viewing student record and academic result. Excuse me. The system aims to streamline the data management process while ensuring data accuracy, security, and accessibility. And the objective of this system is to provide an easy to use interface for managing student data, to minimize data redundancy and ensure information consistency, to allow lecturers to input and view academic results, to improve report generation and academic monitoring. So for now, I'll be explaining about question 1, which is user interface design. So if you see here, this is the key interface. Login screen allows secure access using lecturer credentials, display key statistic and navigation menus, student registration, enables entry and editing of student details. Result entry provides options for adding and updating result in both online and batch modes. Report view displays summary, detail, and exception report for academic performance. So this is a website that we created for our mini project, which is a student portal, and what we got here is login screen, dashboard, student registration, result entry, and report view. So in question B, input design, we have source documents, data entry methods, and validation rules. So what is source documents? It's like student registration form, result entry forms, online and batch. If a student have registered to a course, they can see into this student portal where they can access what's their what's their current status of the registration thing. All they can check here. And data entry methods, online data entry for quick updates, batch processing for bulk uploads and off result. And validation rules, range check ensures marks fall within 0 to 100. Existence checks validate student ID against existing records. Format check ensure proper input structures, for example ID, email, and all these things. Mandatory field check ensures all required files are completed. So this is actually basically what is input design in our question is. So that's it for me. I'm passing my slide to Adira. Thank you.
Thank you to Shabini for hosting me for the next question. For my part is question 1C and question 1D. So first is question 1C is about output design. So this is our design when the display the output from our apps. So as you can still have a summary report, detail report, exception report, input control, output control, access control, and audit log. So we can see the overall of the student use our apps. So the result editor have 862, average grade of the class of B plus. Okay, needs attention for the student to submit the activities or the report is 33. So as you can see, a lot of programmers performance have a computer science, engineering, business experience. So a student, the average of the student take and average score and pass rate. Okay, and then type of report. Type of report, we have summary report that I said before, have a lot of programmer performance. Okay, display overall student performance by class or subject. Student, example is computer science, student is 450, average score is 78.5, and pass rate is 89.2%. For example, the details report provide individual student result breakdown. For example, Ali have their own report. Okay, provide their individual report. Exactly. And lastly, exception report. Exception report is highlight missing or abnormal data. Example, failure of students' data and incomplete entries. Okay. Next is question 1D is about security measure. First of all, input control measure. Uh, use, firstly is user authentication. Each lecturer log in using secure credential to prevent unauthorized access. And second is validation check. It's all entered data is verified to prevent error or injection attack. It's mean validation check like 1 year only six 1 year 2 times check the validation. So if we not check the validation, will be harm our apps, will harm our system, OS, and so on. And next, lastly is access right, role-based access control limit, what user can view or modify. So user only can use modify their personal data, is up to date, update their data, and can view and cannot do anything else because the admin only can do that. The next is about output control measure. First is restricted report access. Only authorized lecturer or administrator can view or export report. Just only one authorized lecturer and admin in our system or every class can access the system and can example like our IPO students have their own website that cannot control the system website, but lecturer website can control the student website by taking their document, attendance, result. Okay, and next is data encryption. Data encryption is sensitive information is encrypted before storage or transmission. And lastly is login and audit trails. So every user action is recorded in an audit log to track access and ensure accountability. That's all from me. I will pass to Eng Jihan for the question 2. Thank you.
Good day, Puan Mageswari. My name is Eng Jiehan and I will be presenting for our mini project for the course System Analysis and Design Fundamentals. So for my part, I will be presenting about the question 2, System Implementation and Support Plan, where we assume we have the deployed and inventory management systems, or the short form is IMS. So for my first part is we should start with a testing plan where it is broken up into 3 types of testing. So for the first testing is unit testing, which is the testing of individual software components or modules in isolation. For in the context of the inventory management system, it is to ensure the function that subtracts stocks when a sale is made returns the correct remaining integer. So let's say you have 100 stocks in the inventory and then you sold 50 of them. So the correct return value should be 50. But if it returns like 70, then there's something wrong with the function. So the second one is integration testing, where it is the testing of combined modules as a group to expose faults in their interaction. So in the context of the IMS, it is to verify that a sales order correctly updates the stock level in the inventory module. So this is basically to ensure that it communicates correctly so it could integrate together perfectly and there aren't any errors or some crashes happening there. So for lastly is our system testing, where it is to test the complete integrated system as a whole to validate all requirements. So in the context of the IMS, it is to simulate a high volume sales day to do some stress testing and verify the UI user interface on store tablets. So the next part I'm going to go through is the maintenance plan, where there are 4 types: corrective, adaptive, perfective, and preventive. So I'll go through them one by one. For the corrective type, the nature is reactive. It is to diagnose and fix errors or bugs reported by users after deployment. So an example we can give is, we fix a bug where the system fails to print a receipt if the total is exactly 0. So let's say the users claimed a lot of discount and their total comes out to 0, but the system fails to print a receipt. So we have to correct that error. So the next one is adaptive. It is a pro or reactive nature. It is to, we will modify the system to cope with changes in the software environment. So let's say the OS or the hardware updates, it has to adapt to that new environment or new operating system so that it could work supposedly. So in the example, yeah, updating the IMS to be compatible with the new OS or new government sales tax rates. So let's say the current government, they implement for probably 10% of sales tax, and let's say another 5 years it updates to 50%, so we have to adapt to that changes. Okay, the next one is perfective. The nature is proactive. It is to implement a new user requirements to improve system performance or maintainability. So an example I can give you is adding a dashboard graph for sales trends or optimizing queries to load faster. So let's say the sales trends is going up by users, but the users requirements are more to this product, so we focus our sales on that. So we perfect our products on the demands of the users. So the last one is preventive. It is a proactive nature. So activities aimed at increasing reliability and preventing future problems. So example is archiving old sales data to prevent the active database from becoming bloated and slow. Let's say you have a lot of sales data from 3 years ago. You can't have it laying bare at the current database because it will cause a lot of stress and the performance will be slow and it could cause crashes. So the next one is user support strategy. We have 2 types of strategy. One of them is users training strategy, where we have role-based training, where for our warehouse staff, we would train them to do barcode scanning and stock entry. Whereas the managers, we will teach them to generate reports or do some system configurations. And we could also do some training materials, like we could provide video tutorials for our employees on example how to add a new vendor whenever there's a new vendor for our company. Other than that, we could create some quick reference cards at the point POS station. So let's say they have to overwrite some updates for the POS system, so there's like a quick shortcut for them to know what to do. And the last one is sandbox environment for safe practice. Let's say a new employee has just entered our company, and before we want them to use the live system, we have to train them on a sandbox environment so they don't accidentally delete or alter any livestock. So if they doesn't have any experience before handling live data, it could result in some business continuity error. So we would like to avoid that. So next is help desk support. So basically, like customer support, we have 3 tiers and a ticketing system. So the tier 1 will be the front line, where they will provide basic queries. So let's say the customers or employees need to reset their password, the tier 1 will help them with that. So the tier 2 will be technical, like functional issues. Let's say the inventory numbers are in sync. The physical product we have is 50, but then in the system it shows there's only 25, so that's a technical error. So for tier 3 is the developer. So basically like code level bugs, if you encounter any code bugs or errors, you have to go through the tier 3 help desk support. And last but not last is our ticketing system. We will use a tool like Jira or Zendesk to track, prioritize, and resolve issues. So for our last one will be backup and security plan. So our backup strategy is to do daily incremental backups. For every 2 a.m. in the morning, it will back up only change data. It is fast and it saves storage. So we will only do full backups during the weekend, or like just Sunday night. It backs up the entire database, so it doesn't take that much of resources. Like if you wanted to full backup every day, it takes a lot of resources and it takes time. So this is our strategy for backups. So our location, we will use the 3-2-1 rule. We will keep 3 copies of data on 2 different media types. So let's say local server and the cloud server, and we will keep 1 copy outside, like cloud or remote, to protect against fire or flood and natural disasters. For our security measures, for our access control, we will implement role-based access controls, where we will give security controls based on their roles. So a cashier should only process sales, while a manager can edit stock levels and view reports. So a cashier cannot they cannot do tasks that is above their roles. So for encryption, however, we have data at rest and data in transit. So for data at rest, we will encrypt the entire database on the hard drive. And for data in transit, however, we will use the SSL or TLS for all moving data. And next, last but not least, audit logs. Our system must record who did what and when for every sensitive actions. So let's say the manager has edited the stock levels, it must have a record that says this manager has updated the record. So we know who does something that is sensitive that could be tracked later on. And lastly, we will implement antivirus and firewalls for every standard deployment on all servers and in terminals, so that in case malwares are attacked, we could prevent it. And we will, for the firewalls, we will prevent unauthorized traffics or users from getting in. That is all from me. Thank you.